Hello, AP PreCal. It's Ms. Kosh again, and I have started with the binomial. We had one video that helped us figure out this. Then we had another video that gave us the first two examples, and now I want to do a third video for these two. I will say these two are a bit of an extension. So if you were totally overwhelmed by the first two videos, get to be, we used to joke, they called it, something was rock solid at school. It was ridiculous. But get really solid on this first part and don't watch this video until you really know what you're doing here, okay? But once you've done that and you want a challenge, come back to these because they're super cool. Okay, so here's what's happening. If you remember from before, to find a particular term, we would do a combination, then we would have this first value raised to a power, and we'd have the second term. So it's, if we have a plus b to the n, I would do a combination n, choose something. I would have a to a power and I would have b to a power. Well, whatever this power is, I like to put a little box here. This power matches, and this, so it would be a different power where the triangle plus the box would add up to n. Okay, so I don't know why. You could use variables. Maybe that's more sophisticated. I like my boxes and my triangles, so hang with me. So on this one, I have 12 choose something, and then I'm going to have x to a power, and I'm going to have this other term, 2 over x squared to the power that is the box value. Okay, so now what I know, they're saying the constant term. The constant term is where I have no x's. So my, well, first of all, triangle plus box needs to equal, it needs to add together to give us 12. Because just like back here, they added 11 and 4 added to give us 15, triangle plus box has to add to give me 12. Now the other thing is if I were to kind of expand this out, let me see, I need some scratch paper. I'm running out of, okay, well this will work for right now. If I were to expand this out, this would be, well, a combination, 12 choose box, and then it would be x to the triangle times 2 to the box times x to the over, I lied, to the 2 box right here. Okay, when it's in the denominator, so you could think of this as x to the triangle over x to the 2 box. And there's, okay, not exactly. There's other stuff out here. There's this out there, there's that out there, but I'm not feeling, I don't want to write that down right now. Basically what happens when we have x to some power over x to some other power, we subtract. Okay, so I don't write that down every time. That was just for you. It was just me. It was special. So this is one triangle, and this is minus 2 box needs to equal. They want this to be the constant. They want us to find the constant. The constant is when the exponent is 0. So I'm looking at the exponent from here. I'm looking at the exponent from here, and I want it to equal the exponent. Notice here I can come along and do a system. I could multiply this by 2, or I could just change the signs on this one. That 0 is still 0. And these triangles cancel. I'm left with 3 box equals 12, which tells me that the box itself equals 4. Okay, so this would be 4. This would be 4, which means that the triangle is 8, and you can't really read what I wrote, but that's what I wrote. Okay, so now we're going to do 12 choose 4 times x to the 8 times 2 over x squared to the 4th power. Okay, so using my calculator, I wanted 12 choose 4. 12 choose 4. So 490, this is 495. This is x to the 8th. This is 2 to the 4th is 16. This is 16 over x to the 8. Notice x to the 8 and x to the 8 will cancel. One's on the top, one's on the bottom. And now I just need to do 496 times 16, and I get 7920, and that is my constant term. The next one follows pretty closely, but they've changed this value. Okay, so instead of finding x to the 0, we want x to the 18. So I have a 10 choose something times I'm going to have x cubed to a power, and then I'm going to have minus 3 over x to the power that's the same value right here. Okay, so I know that triangle plus box needs to equal 10 because the exponents add up to what this power is here. And then I have 3 triangle, and this is a negative, so this would be like x to the negative 1 if I moved it back to the top, minus, so negative 1 box is equal to, oh, I want it to equal 18. And now I'm solving a system. There are 4 triangles. The boxes are gone. That equals 28. My triangle equals, what does my triangle equal? When I divide, I get 7. Therefore, my box is equal to 3. Okay, so coming back, I have 10, choose 3. If I messed up and called it 10, choose 7, remember those are equivalent. And then I have, but it messes me up over here, so don't mess up. 3 to this negative 3 to the third is not the same as negative 3 to the 7th. But the combinations have some symmetry there. Okay, my bad, I digress. The triangle was 7. This is negative 3 over x to the third. I get, to pull out my calculator again, 10. You might notice in my answer key, I forgot to bring home a calculator, and so I was kind of doing it by hand. Did I do that correctly? 10, choose 3, is that what I wanted? Yes, it was 120. So this would be equal to 120 times x to the 21 times a negative 27 over x cubed. Notice I have 21 x's in the numerator and 3 x's in the denominator. When 21 minus 3 is 18. That was good. That's what I wanted. Okay, so now I have x to the 18. Well, what happened here? I have to take 120 and multiply it by negative 27, and I get negative 3240, and there's my answer. I think this is fun. I hope you enjoyed it as much as I did.